Εμείς είμαστε εδώ όμως και έχουμε σαν επόμενο ομιλητή μας τον κύριο John Dillon, είναι Vice President of Marketing στην περιοχή EMEA της Akamai. Mr. Dillon, glad to have you with us.
Thank you. Well, good morning, everybody. Firstly, my apologies for not speaking in Greek. I will try to be as clear and as slow as possible so you can understand. Hopefully the translators will be able to keep up with me as well. And I'm not from any government organization. I work for Akamai, so it's quite interesting to follow the two previous speakers. And I'm going to talk to you this morning about cloud. It's an interesting topic. I think the future of cloud, it would take a very brave person to stand up here and talk about the future without first looking at the origins of cloud and how we've got to where we are today, and then to talk a little bit about where we're headed. So a bit about Akamai. Just a quick question. It's always dangerous to engage an audience that doesn't speak your language. Before this conference, how many of you had heard of Akamai? That's a reasonable number. It's actually frustrating for me. I'm the marketing guy for Akamai in Europe. And as I travel around, and in fact, when I first took this job, I talked to many of my colleagues and they'd never heard of the company. But the reality is all of you probably have used Akamai today. If you've visited one of your social media sites, social networks, if you've watched any video, if you've done any shopping online, bought any tickets, if you've updated the software on your devices, you've probably been using Akamai, because we're delivering every day around 30% of all web traffic. So the chances are pretty much everyone in this room has used Akamai today. We have arguably the largest distributed cloud infrastructure in the world, and actually have servers deployed here in Greece. We started investing in Greece around 10 years ago, and we've been present ever since through our partner Atoll, who are actually on the booth with us today. Our goal has always been, it's a very, very distributed network, our goal has always been to deploy our network as close to the end users as possible. And this diagram, this picture here is not actually a marketing picture. This is actually a real live image of our network today. You can see if I spin it around to Europe, my apologies for those of you at the back, but you can see Europe is heating up. America is still waking up probably right now. And this application is available on the iOS App Store, so the Apple Store. You can actually download this. It's Akamai Net, and you can actually see the Akamai platform live. Right now, down here it's telling me that every second there are 30 million hits on our network. So every second there are 30 million requests hitting our network, and then the next second another 30 million, and the next second another 30 million. So a very, very large infrastructure. As I said, arguably the largest distributed cloud infrastructure in the world. And we started fairly recently. So the company was founded in 1998, so 16 years ago. And the idea behind the company was founded by a professor at MIT and his most promising math student. They developed some algorithms for efficiently managing distribution of traffic on networks, and founded Akamai based on that algorithm. And we've come a long way since then. So we've built a company that's it's around about 2 billion in revenues, 5,000 customers around the world, 5,000 employees, and we are located in 25 countries. So what I thought I'd start with is some early examples of cloud. So has anyone got any idea what was the very first cloud service? What was the first cloud service introduced? So it's storage, which won't surprise a lot of people. So storage was the first cloud service. But actually what was being stored will probably surprise a few people. It's actually water. So cloud, the very first cloud was the cloud that we all know. This is how cloud was given its name. And the way you uploaded to the cloud was evaporation. It was pretty slow. And the way that cloud delivered to us was rain. And in some geographies, the distribution was faster than others. So in the UK in particular, we get a lot of rain. So we had good distribution in the UK, but less so in Athens here. Following the analogy, we built reservoirs so that when the cloud wasn't available, we could store water so that we could still drink and gain access to water. So this was the original I guess, analogy that was used to coin the term cloud in IT. But there have been some other examples. There have been other examples of cloud infrastructure that the IT industry has followed. It's not the first instance of cloud. There have been communication clouds, so the telephone network. When you make a phone call, that phone call is connected in the cloud. We didn't call it the cloud, we called it a telecommunications network, but essentially it was a cloud. Utility clouds, a lot of parallels were drawn on utility computing and the utility industries. And so electricity, the electricity grid, when you needed electricity, you were able to pull it from the grid, so it was available to you on demand. And then broadcast clouds, so cable and satellite TV. Whenever you want to watch programs, whatever you want to watch on your TV, be it via satellite or by cable, again, these are early examples of cloud infrastructure that the IT industry has followed. So some more parallels. This time I'm going to look at how our industry, the software and IT industry, has evolved. So when I joined, my first employer was IBM, and I was a System 370 assembly language programmer, and I was writing applications on mainframes, and those mainframe applications were accessed via dumb terminals. So we had the thin client model. Then we had client server. So Unix was coming out of universities, PCs were showing up on people's desktops, relational databases were happening, and so there was this whole move, and networking, TCP/IP, there was a groundswell of interest around TCP/IP, and so those technologies collided and brought us client-server computing. But then we sort of went back to thin client computing when the web happened. So the internet happened, web browsers appeared on people's desks, web servers, and so we went back to a thin client model. And then Apple, primarily, but many others, drove this move towards thick client again by introducing apps, which we all know about. Everybody, even my grandmother, knows what an app is. And so our industry has kind of breathed in and breathed out. Thin client, thick client, thin client, thick client. And so this evolution has been fueled by developments in technology. And most recently, with smartphones, with mobile networks, with open APIs and cloud, it's created a really interesting environment for our industry. And this is where I go back to my pictures. So this is another industry. So the automotive industry and the software industry and the IT industry is almost caught up with this industry today. So back in the early days of Ford, Henry Ford, they invented the Model T Ford. There was a famous marketing slogan with the Model T Ford, which is you could have any color you liked as long as it was black. There was no customization, it was one car, there was one model, there was no choices, no options as there are today, one car. And Ford manufactured everything on this car. They imported raw materials into their factories, rubber, they made the tires, they made the seats, they made the steering, they made the chassis, they made everything on this car, all of the instrumentation, everything was manufactured by Ford. But if you fast forward to today, Ford isn't really a manufacturing company anymore. Ford is a design and assembly company. They design cars, and they then procure components from third parties, so the instrumentation from Bosch or from whoever, from Garmin if it's satellite navigation, or whoever their suppliers are, but they're essentially buying in components to assemble their cars. And this has allowed them to be very, very agile. They can have many, many different models. They can customize those models to every different customer's actual desires. And so it's allowed them to be much more innovative than they used to be, much more agile than they used to be, and to offer much more choice to their customers. So if you look at software, what's interestingly happened, when I was back in my early days on the mainframe and working for IBM, IBM wrote the entire application. Now, if you're building an application today, say you're building an application for a smartphone, nobody builds the whole application anymore. They assemble their applications out of components. So if I need maps, I'll use APIs from Google to actually pull maps into my application. If I need payment systems, I'll maybe use PayPal. If I want to integrate with social, I'll use Facebook or Twitter APIs. And so applications today are assembled out of components. Those components are available in the cloud. They're accessed via open APIs, invariably over mobile networks from mobile devices. So a huge transformation in our industry, but this is the role that cloud is playing today. Cloud and these other technologies are allowing us to build far more rapidly innovative applications and really allowing that innovation to happen everywhere from the large software companies all the way down to students in their dorm rooms creating new applications and services. So what this is now leading us into, what this environment is creating, is this opportunity to connect anything and everything. So we have this Internet of Things, it's talked about everywhere, where everything, Internet of Everything, human beings. I'm actually speaking later this week at a wearable technology conference, which is another emerging technology area. But pretty much anything and everything is connected. I've seen examples of dustbins in cities that are connected so that when the dust carts are going around to empty them, they can optimize their routes so they don't go to empty bins, they only empty the full ones. I've seen cows connected so that they can monitor the temperature, so that they can, if the cow goes into labor, they can send their GPS coordinates, a vet can get in their car and go out and supervise the birth so that the calf is birth is successful. So all manner of things are getting connected. And what this presents is a number of challenges. And in mathematics, when you have a challenge that's really, really hard to solve, in mathematics it's called the grand challenge. And because our CEO is that former professor from MIT, these are the grand challenges that Akamai is trying to solve today. We're not going to solve all of these alone, but these are where we see the major challenges with cloud technologies, with the internet today. So firstly is providing a super efficient, reliable and high-speed performance on any device, wherever you're connecting over whatever networks, whatever your situation is, making sure you get a great experience. Providing high-quality IP. We talked about the satellite and cable broadcasters being early examples of cloud. Today, with many, many people watching video on IP, it's all about how do we emulate that? How do we provide the same kind of quality of video experience, but over broadband connections? And then finally, if we're going to do all of these things on the internet, how do we do these in a secure way so that people feel confident about using them? They don't feel that their data is being threatened. If businesses are going online, they don't feel that they're going to be attacked. So I'm going to talk about each of these very briefly. I'll go through each one and point out the significance and importance of them. So this is actually a real-life study that was done by Walmart in the United States, which was looking at the responsiveness of their website and the correlation of the responsiveness to transactions completed. So when the website was performing very, very fast, less than a second or less than 3 seconds, they had a very, very high conversion rate. So people were sticking around, they were actually browsing, finding the products they wanted, and they were actually putting them into their basket and purchasing. But as the responsiveness tailed off, so too did the transaction completions. People got fed up. They didn't feel confident that maybe when they're entering their credit card information that the transaction was going to be successful, and so they abandoned and went somewhere else. And what's interesting is, if you look over time, website pages have actually got slower. So back in 2012, the average page load time was around about 6 seconds, just over 6 seconds. But if you fast forward to today, it's around 10 seconds, because the pages have actually got larger, the number of objects on those pages have increased, and increasingly people are accessing these sites over mobile. So in reality, if you look at your average responsiveness as you travel throughout the day from home to the office and when you're out and about, your actual average page load size has decreased. But what hasn't decreased is your expectations. So this is a really interesting statistic, really interesting chart, which shows that our expectations when on a tablet device, for example, are almost the same as when we're on a laptop or on a fixed connection. So we're likely to abandon after 3 seconds if we're on a tablet or on a laptop, and even on a smartphone, 60% of the time. So it's really important to really optimize and make sure that you are providing a great experience on all of these different devices across these devices. And this is the reality today. So on the top retail websites in the United States, the average load time is around 2 seconds. So they've done a lot of work to make sure it works well. But on commerce sites, it's actually 7 seconds. On mobile, sorry. When they're accessing on mobile, it's 7 seconds. And we haven't seen load times at 7 seconds for around 10 years on fixed connections. So a real challenge. We're almost experiencing the internet of yesterday on mobile devices. Now looking at video. Recently we had the World Cup, and Akamai played a significant role. We worked with 50 broadcasters around the world to help them distribute the World Cup games live and on demand over the internet. And this is just comparing what's happened in 4 years. So The average stream size, we've increased the quality, so many connections now are able to take 1.7 megabits and higher, and so many broadcasters were pushing a higher quality bit rate out to their customers. Viewing audiences have gone up over three times. So 1.6 million in 2010, 5 million people viewing the World Cup online this year. And similarly with traffic, a 7 terabits per second peak, that's roughly equivalent to distributing 700,000 DVDs in parallel every hour. And then the total traffic, a phenomenal increase from 29 petabytes in 2010 to 222 petabytes in 2014. So a significant increase. And the same statistics follow. We also did the Sochi Olympics from Russia. And then looking back at the previous, went from 12 petabytes. A petabyte's about 13 years of HD video. So 12 petabytes in 2010 to 81 petabytes in 2014. And the World Cup statistics again. So looking at this problem, looking at this as a problem for the internet, so this is our network. So the Akamai network, is we are working with most of the major broadcasters, as we did the World Cup pretty much. And this is the growth of capacity that we've deployed. So if you look at 2014 where we are now, the highest peak that we've coped with this year is around 26 terabits per second. So a pretty significant peak. But if you do the math, if you imagine, right, today there's around 2.5 billion people watching TV at prime time. And if you say they want to watch it at 4K, so this is the future requirement. 10 megabits per second is roughly what you'd need for a good 4K stream, even with compression and everything else. So that gives you around 25,000 terabits per second would be your peak traffic. So on the previous slide, you saw that currently we're just about coping with 26 terabits. So to go to 25,000 terabits per second, clearly something has to change. So even though many more people are watching video online today, still a long way to go. And finally, security. So nothing is safe online. Every day almost you see stories of websites that are being attacked, new threats that are emerging. Most recently the shell shock attacks or vulnerability. This is actually what we're seeing on our network. So we have to protect, if we're delivering 30% of all web traffic, we have to protect all of our customers. They're major brands, they're major retailers, they're major broadcasters. They want to be protected online. So we protect them online. But this is the number of attacks we're experiencing. So in 2009, we only saw 14 attacks. 2013, we haven't got our statistics yet for 2014. But 2013, over 1,000 attacks, targeted attacks against our customers on our network. So something, again, that is very much an important aspect to be considered when moving to the cloud. So what do we need to do to get where we need to be? So do we need more servers? Looking at that video explosion, is the answer more servers? We have 160,000 of them already. Is that the answer? Is it more efficient hardware and software? Is that something that's going to help? Is it higher capacity connections? Well, the reality is probably all of these things. It's all of these things, but they're not going to solve the problem. And this gets back to the heart of why I think it's really exciting right now what's happening within our industry. When we talked about cloud, standardization of software, open APIs, being able to rapidly build and rapidly innovate, ultimately what's going to be needed to solve these challenges and to build the cloud of the future that can address these challenges is new innovation. Things that we haven't thought about today, ideas, technologies that we haven't put into practice, that's ultimately what's going to be required to move the cloud to be able to address these challenges. And with that, I think I was a few minutes over. Thank you very much.